In class today, you should have graphed both of these graphs. We're going to look at how the multiplication by the 2 on the outside and inside of the function affect the graph of sine of x. So for this first one, when the 2 is on the outside, you should have noticed it made your first point stayed the same, 0, 0. This time at pi over 2, instead of going up 1, it moved your graph up to 2. Pi was still at 0. 3 pi over 2 instead of negative 1 came down to negative 2. And then 2 pi was at 0. So if we graph this, you should notice what it does to the graph, and it keeps going both ways, is that instead of going up to 1, like the normal sine function did, now it goes up to 2. Remember when we did transformations earlier this year, we said anything multiplying on the outside was a vertical stretch or compression? Well, now, to get more specific, the word we're going to use for this in trig graphs is this is the amplitude of the graph. So your amplitude is how far up and down your graph goes. As we get used to these, we're going to kind of create a little grid for ourselves. So just to get you started, our middle of the graph was at 0. Because it was an amplitude of 2, that means the top of our graph was at 2. The bottom of our graph was at negative 2. We're going to get using that a lot, where we say we have a middle of the graph, and then the amplitude is the distance to the top and the distance to the bottom. And you'll get used to seeing that more as we keep going. So now for when we have sine of 2x, this time that 2 is on the inside of the function. So this time when you made your table, you should have noticed it still started at 0, 0. When we went to pi over 4, we were already up at 1. Pi over 2 was back down at 0. 3 pi over 4 was down at negative 1. Then pi was back up at 0. So notice we already have an entire sine graph, and we're only halfway through our usual period. So now up to 1, middle, bottom, middle. If you had made that table, graphed all those points. So this 2 on the inside, if you remember back from when we did all of our transformations before, the 2 on the inside was a horizontal stretch or compression. So now, to be more specific with these trig graphs, what the horizontal compression affects is the period of the graph. And what that means is how often the graph repeats. If you look at this, we had a whole sine curve just by plugging in numbers up to pi instead of going all the way up to 2 pi. That means the new period of this graph is just pi. So when you're multiplying on the inside, it affects the new period of the graph. In order to find that, the way it will always work, since the normal graph has a period of 2 pi, you take that 2 pi, divide it by whatever number's on the inside, so in this case it was a 2, simplify it out, those will cross out, and that's how we know the period of this graph would be pi. So as we get going, we only would graph this first bit up to pi, because we're not going to keep graphing over and over. We know it repeats at this point. So in summary, from the top half of that worksheet, you should have noticed the 2 outside affects the amplitude of the graph, how far up and down the graph goes. The 2 inside affects the period of the graph, which is how much it repeats. Now for the negatives. For these, you should already have your table made. You should have noticed zeros all still were zeros. This time for pi of 2, it normally went up to 1. Now it went down to negative 1. 3 pi over 2 went up to 1. So that's what your new sine graph should have looked like. When the negative's on the inside, you should have noticed as you did the table, the same thing happened. So all your zeros stayed the same. Pi over 2 is at negative 1. 3 pi over 2 is up at 1. So notice, it doesn't matter whether the negative is on the inside or the outside. Again, this takes us back to the fact that sine is an odd function. So it means that f of negative x is the same as having a negative on the outside. So what this means in terms of sine is that sine of negative x is the same as negative sine of x. And we've already talked about that, but the way this will help us with graphing is it doesn't matter if we have a negative on the outside or the inside of the sine function, it'll change the graph the same way. Notice how the reflection works. Just instead of starting up, the graph starts down. So anytime you see a reflection, you know the graph is going to go down first, then come up. So first, a summary just on the basic parent sine function. As we get into graphing all these trig functions, we will always graph two periods of the function. And what that's going to look like is we're going to graph one period to the right of the y-axis, one period to the left of the y-axis. So the normal sine graph has a period of 2 pi, so we would always go to the right 2 pi and to the left 2 pi. As we do these graphs, we're always going to divide this graph up into fourths because that'll give us all of our base points. So to get all these values, essentially this is our halfway mark, so we divide 2 pi in half, we get pi. This is another halfway mark, divide pi in half to get pi over 2. This third mark is 3/4 of the way there, so 3 pi over 2. Same marks to the left, and you will always have to label your graph with all of these no matter what the period is. We'll get used to that. Normal sine graph goes up to 1, down to -1. From here, it's just a matter of knowing the pattern. This is going to be the same for every trig function. Sine starts in the middle, then it goes up to the top, back to the middle, to the bottom, to the middle. It makes a smooth curve. Just continue the pattern going the backwards way. We were up at the top at pi over 2, so now we're going down to the bottom, middle, top, middle. And this is where I said as we get going, we're going to get used to hearing that bottom, middle, top, middle, bottom, middle. It's just a matter of remembering that pattern. Since the amplitude is 1, the top is up at -1. The bottom is at -1. So that is your generic sine graph. So in summary for the transformations, in this bit we talked about amplitude, which is any number multiplying outside the function, so that's your A, and a change in the period, which is any number inside the function, so that's your B. Your amplitude tells you how far up and down the graph goes. So essentially as you're setting your sine graph up, wherever the middle of the graph is, which today is just going to stay at 0, we haven't done any translations yet, whatever your amplitude is, you would count up to that for the top of your graph, count down that value for the bottom of the graph. And then you know the sine curve will just fall in between those two lines. You start in the middle, goes up, down, back to the middle. For the period, so this is how often the graph repeats. As you find your period, you'll do 2 pi divided by b. Whatever value you get from that, that is what you're going to put at the far right end and the far left end of your graph. From there, you'll just be able to divide your graph up into fourths. And again, then you'll follow your pattern, graph sine from there. For the last bit, the reflection, a negative on the outside with A or the inside with B is a reflection. What that does to your graph, so if we have it set up, instead of the graph starting by going up, it would start by going down, then come back up to the middle. So now on the next slides, we're going to do I'll do a few examples for you guys to watch, and then you'll have a few to try on your own.